Hey everybody, today's topic is charcoal canisters and purge systems, especially on GM cars from the 1980s particularly. Probably go into the 70s, and some are probably going to go into the early 90s. This is mostly the pre-OBD2 cars. I've had a couple questions on the channel recently because I posted some video for my 85 Camaro on different things around the purge system and how it works, and what I had to do to make mine work after it sat for a number of years. And as I said, I've had a number of questions on the channel about other cars, other applications. And so what I'm finding is that some of these are fairly complex systems. Here's a picture of a 5-port canister, and I've never seen a 5-port canister before. I've not had a vehicle with one. Or maybe I did and I didn't pay attention because I didn't need to. But each one of these systems is different, and as they come into needing some work, we're having some challenges. The biggest challenge is that for most of the cars of the 70s and 80s, and particularly I'm watching the 80s now, parts are being discontinued. And if you go to the standard parts houses and look for things, they're not there. And so the question comes back from people to me on the channel is, how do we keep our cars running? This video, I'm going to go through some things, but it's probably going to put some principles and suggestions out there. But you'll probably have to be innovative. You're going to have to work at these a little bit. Normally, my view is I would like to keep things stock like this, keep them stock, and keep them going in a standard process, and follow what the original engineers wanted. But when you get to a point where the parts aren't there anymore, and your choice is perhaps to get used parts, which in some cases may not be easy or may not work either. And you've got these complex systems with multiple ports and complex plumbing. The topic here, what I'm going to get into is, what does the engine need? What does the car need in one of these systems? And what are the possible workarounds that you could use to make a functioning system? Like I say, you may have to experiment a little bit, but I'm going to kind of walk through the different systems that I've encountered out of the different service materials that I have, and we'll dig in on this. Now, first of all, you got to understand what the purge system is supposed to do. I mean, ultimately, there are emissions regulations because evaporating fuel going into the atmosphere, into the air, the hydrocarbons create smog in the atmosphere. If the atmospheric conditions are correct with sun and so forth, the hydrocarbons break down in certain chemical processes and create smog. You want to try to minimize that which is evaporating. In regulation, what they do is they have what they call a shed test, but basically you put a car in a sealed room for a period of time and you measure how much fuel evaporates from the car. And it's a very, very small number. So systems were developed with the charcoal canister to pick up from the key sources, store it in the charcoal canister, and then when you fire up the car and drive it, the engine is supposed to pull with vacuum, is supposed to pull that out of the canister and burn that fuel in the engine. And the three key sources are the fuel tank and what evaporates from there and any vents, the float bowl of the carburetor if you have a carbureted car, and in some cases the air cleaner because the carburetor is inside the air cleaner. And fuel injection can have some issues, but typically, because you don't have so much liquid fuel like in the float bowl, the fuel injection systems usually don't have as much trouble with this, because when you shut the engine off, you stop the fuel, it rotates a couple more times and it's done. And especially with port injected, that's the difference between port and TBI, The port injected cars, you're putting the fuel right in at the port. So again, there's not as much to evaporate. But with a carbureted car, the challenges are more complex because you've got a float bowl sitting there with vents, and those vents are letting that fuel out. The second challenge, if you're dealing with 80s cars, is as ECMs came in, some cars got the purge systems controlled by the ECM with solenoids, and some cars had them controlled by thermal vacuum switches and what I want to call them, vacuum control valves. They had more innovative ways to control it. Today, if you go in the OBD2 world with ECMs, typically you've just got a couple of valves that are signaled by the computer, and the systems are functionally simpler in a lot of cases. So I'm not going to tell you to shut off any part of your emission system. The best thing for your car and for clean air is to make these work properly and try to pick up all the sources that your car originally had and get them taken care of. But I'm going to say the most essential thing is picking the vapor up off the fuel tank, because the fuel tank's got a big surface area. It has a lot of vapor that comes out, and in addition, the fuel tank breathes as the temperature varies through the day. It'll pull air in, it'll send air out, it'll pull air in, it'll send air out. And for those of you running ethanol-based fuels, you want to minimize that. The charcoal canister in the control system actually helps minimize that and helps keep that fuel from picking up moisture and going bad on you. Then you got to you also, if you have cars with an in-tank fuel pump, like the fuel injected cars, and there are some carbureted cars that have this too, you have a pressure control valve, a purge valve that limits flow in and out of the tank. Then you need to be able to purge out the canister once it's been filled when you go start the car. And some of the cars, I'll show you some systems where it's pretty much natural, right? There are some truck systems particularly where the vacuum just picks up and brings the fuel vapors out and pulls them out. But some of the time you end up with, in order to get the performance right, you need control with the throttle. And so my Camaro, when you tip the throttle open, the ECM goes, oh, the throttle's open, and it opens up the purge valve electrically. It says two things. It says the throttle's open and the engine's warm, and then it allows vapors to go in and get burned. And if it didn't have that control, I could tell you that the idle would probably be rough and the engine doesn't perform really well in all circumstances. So some engines need a throttle control and some of them need a temperature control. The float bowl, especially on the carbureted cars, the bowl vents often go into the canister system as well, because you don't want that fuel coming off. It's maybe not as important as the fuel tank, but you don't want to forget about it because you don't want to plug off the bowl vents, I'll put it that way. You got certain things that will upset how the carburetor operates. So what can you do? I already said you can go find used parts. A lot of times you can go, find things through eBay or through other sources and find something off an older car that maybe has a good part and bring it into yours. You can improvise with some modified parts, and I'm going to show you some things. And you could repair the existing. For example, if you have a bad canister, I'm not going to show you how to do that here, but I've seen videos on YouTube where people have taken their canisters, taken the bottom off. You can buy carbon. You can take the carbon out and replace it and put it back together. And sometimes that's a good method. When you get into these, it depends, is your canister bad? Is your solenoid bad? Is your plumbing bad? Or do you have a vacuum valve that's bad? You need to determine from using your service information what what's there. Now, I'm going to repeat this one more time. This is going to be a do-it-yourself project. I can't tell you exactly how to do this. I'm going to give you some principles to think about if you're trying to go fix your car. And I'm going to leave it up to you. I can't guarantee, that what you do will work. But you need, if you want to keep driving your car, you need to do something. And it's best, I'm going to say, not to take the canister off and try to let the tank vent out to atmosphere. Both for pollution and your car will smell and safety issues. It's far better to try to make this system work if you can. Now I'm going to go back to that 5-port canister because I had never seen one of these before, but somebody asked me about it and said, what do you do with a 5-port canister? And I hunted around and did some searches for 5-port canister, on the internet, and came up with some of the information I'm going to show you came from other sources. I think this one was from a site called Square Body, which is a truck site, a forum site, and I pulled a lot out of service information that I have in my hands at my disposal. I don't have a lot of service information for every vehicle, but I have a few different things, so I pulled from that. Also, I'm going to apologize to someone on the channel who had asked me about canisters. He couldn't find a filter on the bottom of his canister. And I said that I hadn't ever seen one that way. Every car I've had that had a canister had a filter on the bottom. Well, but I told him there was probably some exceptions because I don't know everything. And here's one that has an air inlet up at the top on a hose. It's number 4, and number 4 goes up to the air cleaner. So to my comment earlier about air cleaner, what they're doing here is they're pulling fresh air out of the air cleaner and drawing it through the charcoal canister. And then this canister has got separate sections, and there's one section, here's 8 and 9, it's ported vacuum to signal it, and 9 is vapor to the purge line. This would go into the intake manifold, and then this guy would be the signal to purge this one. So you've got one that's doing, let's see, where's number 5? Here's vapor from the fuel tank. Here's number 7 or 6, and 6 is vapor from the bowl vent. So these two are getting, this is controlling from the carburetor. And so what they've done, in fact, it kind of looks like, I haven't had this part, so I'm using cross section, but it looks like the fuel tank is going in, feeding the outer section of the carbon, and this one in the middle is picking up the float bowl vents on the carburetor. And it's like having 2 canisters in one. Now, I've been looking, and this canister is no longer available from any site that I can find. So what do? You could potentially tear it apart and replace the carbon, or you could potentially replace it with 2 different canisters, perhaps, that are, I'll call them 2-port canisters. Well, stay tuned for a minute. Now this is one that I found from a Corvette site that shows kind of how one of these multi-port, and I think this was a 4-port canister, but here's your canister with a line from the fuel tank, and there's a purge control valve, and it's feeding the vapor into the PCV hose, just using the PCV hose to get manifold vacuum. So it's feeding fuel vapor straight into the base of the carburetor. And then the ported vacuum, which actually is going to the EGR system as well, has a thermal vacuum switch. This is the part about, is the engine warm or cold? And then this is ported vacuum, which is a port that's above the throttle plate. So this port, this is to my comment about the throttle needs to be open. When you tip the throttle open, this port gets vacuum on it and starts, so in this case, if the engine is warm and the throttle is cracked open, it will feed vacuum not only to the EGR valve, but over here to the canister and start purging. This is a truck one from high altitude, and this isn't even, I'm going to say isn't the simplest one because it's got a little more plumbing in it. But it's pulling vapor off the tank through a control valve, through the canister, and then here's the manifold vacuum is 11, and here's the ported vacuum. This is a throttle body engine. Here's the ported vacuum. So when you crack the throttle open, you'll get vacuum on here that will open up this valve and let the manifold vacuum pull air from number 3 through the system and feed the system over here. And here's a little better look at what that canister looks like. There's the vapor line. Here's air coming in. Here's the control and the control and the purge line. Now here's one, and I owned one of these cars. This is a 5-liter VIN Y, and then the 3.8. This is what the Oldsmobile and the Buick engines were using in the mid-80s. This comes out of my 1985 book. And instead of using a 5-port canister, they use a 2-port canister, one of these thermal vacuum switches, and then this dude in the middle here is this valve. And up until recently, this valve, you could buy this valve. But what this valve does, you can see here's the line coming off of the float bowl of the carburetor into that valve. 13 is manifold vacuum. So what once again you're going to do is, fuel tanks feeding vapor. When you run the engine, it's going to pull vapor off through this, when the engine's warm, through this switch, over through this valve. This valve is signaled by the ported, when you tip in the throttle, ported vacuum will trigger this valve, and then manifold vacuum pulling here will take vapors off out of the canister. And I believe the way that this valve is situated is that when the engine is off, the vapors from the float bowl will feed into the canister as well. Not quite sure about that because I haven't figured out all the mechanization, but it would seem that if it's warm and this valve is open and this is off, you probably have a path where vapors can be collected. If you want to see what one of those valves looked like, this is what it looks like schematically in the service manual, and this is the valve. Standard Motor Products has this in their electronic catalog, but I can't find it anywhere. It's gone. Now, again, if you were trying to design your own, say replace a 5-port canister with a 2-port canister, and you go find one of these 3.8 or 5.0 valves, one of these valves, you could probably build yourself a system with a 2-port canister that would do the same thing as your 5-port canister. You just have to track down the ports on one of these valves. If you got a Camaro, a carbureted Camaro, again in the 85 time frame, they had one of these valves. And this valve, again, let's use a simpler canister, but it gets all of the different functions from manifold vacuum to carburetor bowls and so forth. And again, let's use a simpler charcoal canister to pick up everything and feed it into the engine. One that's kind of interesting here, this is from a 2.8. I'm going to show you several pages here from a 2.8 V6. Again, here's a 2-port canister, and they have this one here, number 3 this is the solenoid for the float bowl. It's triggered by the ECM. You can see it comes off the carburetor and feeds into the canister, and it's teed in to this other valve. And number 5 is the purge solenoid. And you can kind of see how this all comes together. Here's a little different picture of the same thing, kind of showing the plumbing of where they feed that to. And here's the mechanization diagram of that. Okay, they've got a canister purge solenoid that's normally open. Now that's going to cause some challenges too. But here's this, I want to call it a valve, but it's not really a valve. This junction block that picks up, that has different restrictions. So they put ported vacuums here. There's an 80 thousandths, there's a 30 thousandths, and all these lines connect. It both feeds the canister and it feeds the intake manifold to purge. And this is what that looks like in a little more detail. Then I said you need a valve on the fuel tank, and this is the one for my 85 Camaro, the CP111. There are several of these available through this, Standard Motor Products and some other sites, and they may have slightly different orifices and settings in them, so it's really best if you find the one for your car. But if you don't, if you're inventing, right, you need something similar to this, and it may be, some of these valves I think are the same inside, it's just the different size of ports on them, and others have some different orifices in them. You got to go check. But this is what that valve looks like inside. It has an orifice, it has a tube for the fuel tank over here, it has a tube to the canister, and then you trigger this off the ported vacuum. Well, this one says tube to manifold vacuum. There may be some engines that do that, but on the Camaro that comes off a ported vacuum. Again, that it doesn't feed unless the throttle is cracked open. But I'm going to say it may vary from car to car, so you need to watch. Most of the canisters are gone, but this one goes from 1974 to 95 with a break in the middle, it says. But this is a 2-port canister that comes from Dorman. Looks like that. And so it'll have a passageway that picks up from the tank or from whatever your sources are, and it'll have one that's supposed to feed outward. If I got in trouble on my 85 Camaro, it has the solenoid built into the port. And if that solenoid ever dies, I would probably need to do is find one like this and figure out how to put an external solenoid valve on it. And here's an example of what that looks like inside. This port number 1 is blocked, so you only have a 2 and a 3. And then the air inlet on this one is down on the bottom. So here I'm going to flip back to one and say this looks like, this is the most basic way to get your system to purge. And when the factory engineers were working on these systems, they have specs, right? The system has to be able to purge within so many seconds when they're running a federal compliance test. And so a lot of times the specs and the valves and the way everything operates is very, very specific to the application to make sure it meets the law by the government's requirement. If you're in a car that's 30 years old and you're trying to make this work, you've got a little bit more latitude. You want it to work, but if it worked in a minute and a half instead of a minute, the world would still be okay. So your requirements maybe are a little looser, maybe not quite as tight. Anyway, this is the most basic one. This came off of a 4.3 and a V8 truck in, well, this would be about, see, it says 1987, so this is about late 80s. But they had a 2-port canister with the air inlet on the top. Vapor comes through an orifice off the tank, fills up the canister, and then they just purge off of cracking the throttle open and using the ported vacuum direct. There's no valve at all. So this would be, if you were trying to make yours work, and you have a carburetor with ported vacuum, you could run this direct. Now, you might also find that there's way too much purge this way, and that when you tip in that your engine stumbles and hesitates and doesn't want to run right, because you get too much fuel all at once. And so that's where some of these regulating orifices come in. And like I say, you may have to tinker a little bit. You may have to add a control solenoid, or you may have a control solenoid. If you have an ECM controlled canister today, you may need to have a control solenoid, and it could be normally open or normally closed, depends on your car. Now, if I was having trouble with this running, suppose I had a carbureted Camaro that didn't have ECM control, and I was forced into using one of these, I could put a solenoid valve in there, and I could run it and put I'll call it a micro switch on it, build a little bracket, and put it on the throttle linkage, so that, the switch doesn't trip until I'm into the throttle a little ways, and then it would start to pull purge. That'd be one way to slow it down for you. The second is, if you do have an in-tank pump, you need to get one of those, like the CP111, you need to get one of those valves that gets triggered again probably by ported vacuum. And I've seen some carburetor cars that use these, and I haven't been able to track them all down, but I know that if you don't have one of these valves with, like my Camaro with an in-tank pump, the tank holds a couple of PSI, 1 or 2, thereabouts, but that little bit of pressure when the tank gets hot suppresses some of the vapor and keeps the pump from cavitating or pulling fuel vapor when the fuel is about ready to boil. And so that valve's on my car. I tried driving it around. I was diagnosing the system. My car, that valve was bad after it sat for 25 years. And you can go back and look at my older videos, and I've got a couple out there that describe this. So I drove it around for a few days with the line open so that the tank was just venting out to atmosphere. And it was summertime. And with that being the case, when the tank got hot, the fuel pump would get noisy, and then the engine didn't want to run quite right, especially at idle. And when I put that valve back in there, when I got a new one and plumbed it in correctly, all of that went away, all of it. 90% of it went away. Once in a while, on a really, really hot day, driving in really heavy traffic, slow traffic, you could still get a little bit of pump noise once in a while. But I haven't had the car quit running again, which I did when that valve wasn't there. So just going back to this one, which is the basic, this is the most basic one that you can get, right? It just puts vapor in here and pulls it out. Then, if I was running a carbureted car, I know this still shows a throttle body, but if you were running a carbureted car, you may want to have this number 8, which is a thermostatic vacuum switch in there that goes into the water jacket, into the coolant system. And those parts, I think, are generally still available. You want something, that as the engine warms up, opens up and allows it to feed. Then, I said earlier, there are normally open and normally closed solenoid valves. And in the 80s, a lot of these cars used normally open valves that then the ECM closed. I don't know why they chose one or the other, but from what I can tell, the purge valves that were normally open are no longer available either. A little while back, if you go look at one of my earlier videos on EGR, my car, my 85, has a normally open EGR solenoid, and it's no longer available. And I was looking for a substitute. Again, someone asked me on the channel, and I found that this one, which is used on a Cadillac, this is a VS25, this one was used on a Cadillac 4.5, 4.9, it's a normally open solenoid for EGR. I think you could use it, you'd have to experiment, but I think you could use it as a purge solenoid that's normally open if you needed a replacement. With the exception that this one has, there's a port on the back, there's a port here on the front, and there's a second one that gets a filter. This is a vent. And you need the vent so that if you're running an EGR valve with a diaphragm in it, when you turn it off, you need that EGR valve to be able to vent out and close. If I was using this for purge, I would find a way to cap this off, maybe put a line on it, a hose on it that's capped on the other end so that it can't vent. Because all you would want is for it to feed directly through. I'm not sure that it would work for you, but I would sure try it. Then I'm going to say kind of finally is if you just needed a normally closed purge solenoid, this is one that's used. You can see there are a lot of applications here, and this one is a GM one, that covers a lot in the early 90s and even beyond. For those cars that went when they started going to a normally closed purge solenoid. Now I'm going to go one step further. I didn't have time today to go into it, but I think with some innovation, if you're electrically inclined and you're good with 12-volt power and solenoids and relays, I think you could. I haven't done this, but I think you could take a 12-volt relay and connect it to a normally closed purge solenoid and make the logic so that it reverses operation. So that, I'll say, it'll be closed when the car's off. But you could wire it with a fused line off of something that's goes on with ignition and make it behave like normally open using a relay in between. So 12-volt power to a relay that would trip and make this work the way you wanted it. If you had say you got an ECM control that's looking for a normally open solenoid, I think you could find. I think there might be a way. I haven't sat down and drawn it. I don't have time this afternoon, but it's something worth thinking about. But that's kind of a really high-level, broad brush view of what all of these systems looked like and what they did. And ultimately, you got to remember that the basics are that you want to get the fuel vapor out of the tank into the canister. You want a good canister. You want to have the fuel vapor from the float bowl get into the canister. And you might even be able to do that by putting the two lines together in a T and just, having them feed in. Looking at that 2.8 liter with the different feed orifices, I mean, every engine and every fuel tank is a little bit different. But if it were me, I would go in and I would look at some of these options for trying to figure out how to modify the factory system a little bit so that I had a working canister and could purge it out, protect clean air, make things work to the best that you can. And maybe you can find some used parts, out of another older car. Maybe you can rebuild your canister. Number of choices that you could have here. But this is a case where I can't show you how to do it. Every car is going to be different. But I thought perhaps by giving you some of the basic principles, you'd have a chance to understand what it is that you need to do and take a shot at it. So I hope that helps, and that's all for now.